In 1953 in Dearborn, Michigan, the Ford Motor Company quietly killed the engine that had defined its identity. The last American-made Flathead V8 rolled off the assembly line, permanently replaced by the modern overhead valve Y block. By the engineering standards of the day, the Flathead was an overheating, poorly breathing piece of pre-war iron that should have faded into scrap. Instead, its factory death triggered an explosion. Because the Flathead was officially obsolete, its price plummeted. Across Southern California dry lakes and Midwestern dirt tracks, returning GIs and young mechanics suddenly had access to cheap, disposable V8 power. They dragged these cast iron blocks out of salvage yards, bolted on finned aluminum heads, and started breaking speed records. The paradox was perfect. The exact moment Detroit abandoned the engine, the American street claimed it. But the real story of the Ford Flathead V8 is not only the story of an outdated engine leaving a factory in 1953, it is the story of how a single piece of cast iron gave birth to $1 billion aftermarket, taught an entire country how to go fast, and defined what horsepower meant before the world moved on. Every week, we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place in Dearborn, Michigan in 1932. Before 1932, if an American driver wanted to move faster than the rattling pace of a four-cylinder engine, they had to be wealthy. The American highway system was beginning to stretch across the continent, replacing dirt wagon trails with paved routes. But the machines available to the working class were fundamentally slow. The Ford Model A, introduced in 1927 to replace the aging Model T, was a reliable machine, but it was a utilitarian one. It was designed to pull a family to church or a farmer to town, not to conquer vast distances at high speed. At the upper edge of the market, the V8 engine, an 8-cylinder engine with cylinders arranged in two banks in a V shape, was a symbol of absolute luxury. Companies like Cadillac and Lincoln built massive, quiet, powerful V8s for bank presidents, factory owners, and the Hollywood elite. But these engines were fiercely expensive to manufacture. Early luxury V8s were not made from a single piece of metal. They were cast in pairs or blocks of 4, then painstakingly bolted to a separate crankcase. The machining required tight tolerances, and the assembly required highly skilled labor. The V8 was an engine of privilege. In Dearborn, Michigan, Henry Ford watched the market shifting. Chevrolet had introduced a smooth-running inline-6, a 6-cylinder engine arranged in one straight line, that was starting to make Ford's 4-cylinder engines feel unrefined. Ford knew he needed to leapfrog the competition. He did not just want 6 cylinders, he wanted 8. And he wanted to sell them to the same farmers, clerks, and factory workers who had bought the Model T. To do that, the price had to be impossibly low. The only way to make a V8 engine cheap enough for the American working class was to cast the entire engine block, the main iron structure that holds the cylinders and major internal parts, as a single unbroken piece of metal. In metallurgical terms, casting a V8 on block for mass production was considered nearly impossible. Inside the massive River Rouge complex in Michigan, a sprawling industrial empire where raw iron ore went in one end and finished cars came out the other, Ford's engineers and metallurgists went to work in absolute secrecy. The process was a nightmare of heat, sand, and failure. To cast a V8 block in one piece, workers had to create complex, fragile sand cores that would form the hollow water jackets and cylinder bores when molten iron was poured around them. If the sand shifted even a fraction of an inch during the pour, the cylinder walls would be too thin, the water jackets would leak, and the block would be ruined. The early scrap rates in the Rouge foundry were staggering. Molds collapsed. Blocks cracked as they cooled. Molten iron burned through the sand. But Henry Ford refused to back down, forcing production chief Charlie Sorensen and his foundry men to refine the process until the failure rate dropped. They developed new methods of baking the sand cores and securing them with metal pins so they could withstand the violent rush of liquid iron. By March 31, 1932, the impossible was ready for the American market. Ford unveiled the Model 18. Under its hood sat the first mass-produced single-cast V8 engine in history. It had a displacement, the total volume swept by the pistons inside the cylinders, of 221 cubic inches. It produced 65 horsepower, a staggering figure for a low-priced car at the time, and generated a wave of smooth, low-end torque, the twisting force that drivers felt as raw pulling strength when they stepped on the gas. And it was cheap. A new 1932 Ford V8 Roadster started at just $460. Overnight, the mechanical hierarchy of the American road was shattered. A young mechanic, a rural farmer, or a traveling salesman could now buy the same cylinder count that had previously been reserved for luxury sedans. The engine was simple, tough, and easily understood by anyone with a basic set of tools. But early adoption was not entirely smooth. Because the River Rouge foundry was still perfecting the casting process, some of the early 1932 blocks suffered from porous metal that leaked oil or water. The engine consumed oil at high rates. The water pumps, mounted high on the block, were prone to leaking, and the fuel pump design had to be revised. Yet the American public forgave the flaws because of the sheer thrill of the power. The engine sounded different than anything the working class had ever driven. It had a deep, rhythmic, uneven idle that sounded muscular and purposeful. It pulled up steep grades in high gear. It cruised at 60 miles per hour on the new paved highways without vibrating itself to pieces. The engine quickly found its believers. Truck fleets bought them for delivery routes. Farmers used them to haul heavy loads to market. Police departments realized they needed them to catch criminals on the open road. And, famously, the outlaws realized they needed them to outrun the police. Surviving folklore and historical documentation heavily point to bank robbers and bootleggers, heavily favoring the Ford V8 for its unmatched power-to-weight ratio. The legendary, though debated letter sent by outlaw Clyde Barrow to Henry Ford in 1934 praised the V8 as a getaway car, writing that he drove Fords exclusively when I could get away with one. Whether the letter was genuine or a piece of American myth-making, the sentiment was entirely real. The engine had democratized horsepower. It had taken the V8 down from the luxury pedestal and put it into the dirt, the mud, and the gravel of rural America. The block was finally affordable and out in the world. But Ford had no idea what the American public was about to do with it. To understand why the Ford V8 reshaped American mechanical culture, you have to look under its hood and understand exactly how it was built. It was fundamentally different from the high-performance engines that would eventually replace it. The Ford V8 was a flathead, an engine design where the valves sit down inside the engine block rather than up in the cylinder head. In a modern overhead valve engine, the valves, the mechanical doors that open and close to let a mixture of fuel and air into the engine and push hot exhaust gases out, are housed directly above the pistons in the cylinder head, the upper metal casting that bolts onto the engine block to seal the cylinders. But Henry Ford and his engineers chose the older, simpler L-head configuration. In this design, the valves sit directly next to the pistons inside the main iron block. As a result, the cylinder head on a Ford Flathead V8 was essentially just a heavy flat lid of cast iron with hollow passages for cooling water. It contained no moving mechanical parts whatsoever. For an automotive engineer looking for maximum efficiency, this design was deeply compromised. The incoming air and fuel had to make a sharp, inefficient 90-degree turn to get from the valves up and over into the combustion chamber. But for the American consumer in the 1930s, this mechanical simplicity was a revelation. Because the cylinder heads were just solid slabs of bolted metal, the engine was incredibly easy to service. In a rural dirt driveway in Kansas, or a small service station in Ohio, a mechanic or a farmer could grab a standard wrench, unbolt the 21 studs holding the head in place, and lift it entirely off the engine. In a single Saturday afternoon, they could scrape carbon buildup off the tops of the pistons, replace a blown gasket, and bolt the whole machine back together. You did not need a specialized dealership, a complex set of factory tools, or an engineering degree to keep a flathead running. The engine invited ordinary people to take it apart, and once Americans realized how easy it was to take apart, they figured out how to make it go much faster. The earliest pioneers of modifying the flathead were not factory engineers in Detroit. They were outlaws and independent mechanics operating in the shadows of the Great Depression. In the rural South, bootleggers transporting illegal moonshine through twisting mountain roads needed cars that looked like ordinary Ford coupes on the outside, but possessed enough raw speed to outrun federal agents. They quickly discovered that the Flathead's simple architecture made it the perfect blank canvas for performance tuning. Because the cylinder head was just a flat piece of iron, mechanics realized they could place it on a milling machine and shave a thin layer of metal off the bottom. When they bolted the shaved head back onto the block, the space inside the combustion chamber was smaller. This increased the engine's compression, the squeezing of the air-fuel mixture inside the cylinder before the spark plug ignites it. Higher compression created a more violent explosion, which instantly yielded more horsepower. This was the genesis of American bolt-on performance. The bootleggers and early dirt track racers learned to manipulate the engine's breathing. They modified the carburetor, the mechanical device sitting on top of the engine that mixes liquid gasoline with outside air before drawing it down into the cylinders. They experimented with different intake manifolds, the cast metal passages that route that air-fuel mixture from the carburetor to the internal valves. If one carburetor was good, mechanics figured out how to cut and weld manifolds to accept two carburetors, force-feeding the cylinders with more fuel than the Ford factory ever intended. They also unbolted the restrictive factory exhaust manifolds, the cast iron pipes that collect hot exhaust gases from the cylinders and route them away from the engine, and fabricated custom dual exhaust systems. This not only helped the engine exhale better, but it gave the Flathead its signature sound, a deep, throaty, staccato burble that echoed through the Appalachian foothills in the dead of night. That sound became a calling card, a mechanical signature of outlaw rebellion. Throughout the late 1930s, the Ford Flathead V8 dominated early American stock car racing. On dusty oval tracks carved into Midwestern County fairgrounds, drivers stripped the heavy fenders and bumpers off 1932 and 1934 Ford coupes to reduce weight, relying on the Flathead's low-end torque to pull them out of dirt corners. The engine proved wildly durable under severe abuse. Its forged steel connecting rods, the heavy metal arms that linked the pistons to the spinning crankshaft, could handle the stress of high-speed racing far better than the weaker components found in cheaper competitor engines. While Chevrolet heavily promoted its inline-six, touting its more modern overhead valve design, the Chevy simply could not match the V8's raw twisting force or its structural rigidity when pushed to the absolute limit. The Flathead block was a massive single chunk of iron that tied the whole vehicle's powertrain together. In Southern California, a few early speed pioneers began testing these modified Ford engines on the vast, flat expanses of the Mojave Desert's dry lake beds. Men like Vic Edelbrock Sr. started tinkering with the Flathead in the late 1930s, buying cheap roadsters and figuring out how to cast his own aluminum intake manifolds. Edelbrock's early experiments proved that the Flathead's breathing limitations could be overcome with clever engineering outside of the Ford Motor Company. He wasn't backed by corporate funding. He was a guy in a small Los Angeles garage figuring out how to make Henry Ford's mass-market machine run harder. By the end of the decade, a quiet, decentralized industry had begun to form around this single-engine family. Small machine shops and independent speed equipment makers started casting their own custom cylinder heads out of aluminum, a metal that was lighter and dissipated heat far faster than factory cast iron. A mechanic could now buy a stock Ford V8, order a few aftermarket parts through a catalog, bolt them on in a home garage, and completely transform the machine's output. Power was no longer dictated strictly by the factory that built the car. Power now belonged to whoever had the tools, the parts, and the courage to push the iron past its original limits. The Ford Flathead V8 had successfully bridged the gap between basic transportation and high-speed potential. It had become the engine of the outlaw and the everyday worker. But it would take a world war, a massive shift in mechanical skill, and a generation of young men returning to the dry lake beds to turn this cheap iron block into an absolute American empire. By 1945, the United States had fundamentally transformed, and a new kind of mechanical appetite was returning from overseas. World War II had trained millions of young American men in the brutal, high-stakes arts of mechanical survival. Pilots, tank mechanics, and motor pool technicians returned home from Europe and the Pacific to a civilian world that suddenly felt too slow. They had just spent 4 years tuning Pratt & Whitney aircraft radials and Packard Marine engines to their absolute limits, learning how to manipulate airflow, compression, and fuel mixtures to keep heavy machinery alive in combat. When they got back to places like Los Angeles, California, or the rural stretches of the Midwest, they had discharge pay in their pockets, surplus tools in their hands, and a desperate need for adrenaline. They did not go to Ford dealerships to buy heavy, expensive new cars. They went to the salvage yards. Waiting for them in the weeds and dirt were thousands of discarded pre-war Ford Flatheads, especially the lightweight 1932 Model 18s and the streamlined 1934 coupes. Because Detroit had moved on to newer designs, these old cars were viewed as cheap, disposable transportation. To a returning GI, they were blank canvases. This was the exact moment the Flathead transcended being just a mass-market car engine and became the foundation of a new American subculture, the hot rod. In an America where an engine could decide whether a field was cut, a truck made its delivery, a boat left the dock, a generator carried a hospital through a storm, or a plane lifted from the runway, power was not an abstraction. It was iron, fuel, labor, heat, sound, repair, and trust. For this new generation, that power was found on the dry lakes. In Southern California, vast flat expanses of baked earth, specifically El Mirage and Harper Dry Lake, became the proving grounds. Young men dragged stripped-down Ford coupes out to the dust, painted numbers on the doors, and pushed the cast-iron blocks until they screamed. This was no longer just about shaving a cylinder head in a bootlegger's barn. This was the birth of a formalized, highly organized American speed industry. Small machine shops in the San Fernando Valley and Los Angeles began mass-producing flathead speed equipment, turning backyard tuning into a multi-million-dollar aftermarket. Vic Edelbrock, operating out of his own shop, perfected the slingshot aluminum intake manifold, a cast aluminum passage system that allowed multiple carburetors to feed the engine evenly, curing the Flathead's natural starvation for fuel. Fred Offenhauser, whose name would become legendary in American racing, machined heavily finned aluminum cylinder heads. These heads did not just raise the engine's compression. The tall aluminum fins drew heat away from the block far faster than the factory cast iron parts ever could, keeping the notoriously hot engines alive during sustained high-speed runs. A few miles away, Ed Iskenderian began grinding custom camshafts, the rotating shafts inside the block that dictate exactly when and for how long the engine's internal valves stay open. A more aggressive Isky camshaft meant the engine could gulp more air and fuel at high speeds, shifting the power band higher into the RPM range. Barney Navarro designed innovative fuel layouts, and Alex Zidias opened the SoCal Speed Shop in Burbank, turning the sale of these specialized flathead parts into a legitimate retail empire. Mechanics also began heavily machining the iron block itself. They learned to port and relieve the block, using grinders to carve away the cast iron between the valves and the cylinders, creating a smoother, wider path for the air-fuel mixture to flow. They bored the cylinders, using heavy machining equipment to widen the holes inside the block so they could fit larger pistons, physically increasing the displacement of the engine. They stroked the engines, swapping the stock Ford crankshaft for a modified one, often taken from a Mercury V8, Ford's slightly more upscale and larger displacement brand. This longer stroke pulled the pistons further down into the cylinders, creating a massive vacuum on the intake stroke and generating ferocious low-end torque. By 1948, an entire cultural ecosystem had grown around this one specific piece of Ford iron. Hot Rod magazine launched that same year, founded by Robert Peterson, with a modified Ford Roadster on the cover of its first issue. The catalog industry exploded, allowing a teenager in Ohio to mail order the exact same aluminum heads being raced in California. The aftermarket had arrived, and it was entirely fluent in flathead. The engine was now the undisputed king of American performance, a cheap piece of iron that had birthed a sprawling network of foundries, speed shops, and retail counters. But as the young mechanics pushed the iron faster and harder across the dry lakes, they were beginning to hit a thermal wall that no amount of aluminum could fix. While the hot rodders were busy turning salvage yard blocks into racing machines on the West Coast, the Ford Motor Company was fighting for its corporate life back in Detroit. Following World War II, Henry Ford passed away, leaving his grandson, Henry Ford II, in charge of a crumbling, financially bleeding empire. Ford desperately needed a miracle to avoid bankruptcy, and he bet the entire survival of the company on a completely new, modernized car for the post-war era. That car was the 1949 Ford, often called the shoebox for its sleek, slab-sided styling. It looked like the future, but under the hood of this modern steel body sat the 8BA, the final, most refined iteration of the Flathead V8. The 8BA was a modernized piece of iron. Ford engineers had finally redesigned the problematic cooling system, moving the water pumps to the front of the block and installing a more conventional, reliable ignition distributor. The displacement was bumped to 239 cubic inches, and factory output reached an honest 100 horsepower. The scale of the Flathead's presence in American life during this period is almost impossible to overstate. Millions of these blocks were cast in the massive foundries of the River Rouge plant. The Flathead did not just power the rebellious hot rods in California, it was the rhythmic heartbeat of mainstream America. It sat beneath the hoods of the new Ford F1 pickup trucks, hauling lumber and farm equipment across the Midwest. It powered police cruisers chasing down smugglers in the Deep South. It pushed heavy family sedans along the newly expanding stretches of Route 66. Simultaneously, the outlaw culture that had embraced the engine began to legitimize. In 1950, C.J. Hart opened the Santa Ana drag strip on an abandoned airstrip in Southern California. This was the birth of commercial drag racing, a place where young mechanics could legally race their cars against the clock, rather than running from the police on public streets. The undisputed weapon of choice at Santa Ana was the Ford Flathead. The engine was no longer just a machine, it was a cultural identity. An American teenager with a part-time job could buy a beat-up 1932 coupe for $50, save up for an Edelbrock aluminum manifold, scavenge a pair of Stromberg carburetors, the fuel-mixing devices favored by the speed crowd, and suddenly possess the fastest machine in their county. It was the absolute democratization of speed. The Flathead had birthed an entire ecosystem of speed shops, parts counters, catalog mail orders, and machine shops dedicated solely to keeping this specific engine at the front of the pack. By the early 1950s, the Ford Flathead V8 was the reigning king of American horsepower. It was cheap, it was everywhere, and it was backed by a massive, fanatical service network of independent builders. But the Flathead had become an empire built on a flawed foundation. The very design that made the engine so cheap to produce and so easy for a teenager to modify was hiding a physical limit that no amount of aftermarket aluminum could ever overcome. The first crack in the Flathead empire was almost invisible. It did not start in the Ford boardroom, and it did not start with a drop in sales. It started as a faint hiss of steam in the pits of the Santa Ana drag strip and on the baked earth of El Mirage. The problem was not a lack of enthusiasm. The problem was the physical limit of the iron itself. The very architecture that made the Flathead so cheap to build and so easy to modify, the valves sitting deep inside the block, contained a fatal engineering trap. When a fuel mixture detonated inside a Flathead cylinder, the violently hot exhaust gases could not simply exit out the top of the engine like they do in a modern vehicle. Instead, the exhaust had to travel back down and squeeze through a passage cast directly through the engine block, entirely surrounded by the engine's liquid cooling passages, before finally exiting the vehicle. For a farmer hauling hay at 40 miles per hour, this design was perfectly fine. But when an American teenager bolted on dual carburetors, shaved the cylinder heads, and held the throttle wide open for a quarter-mile sprint, the engine essentially tried to boil its own cooling water. The exhaust heat transferred directly into the block. The Flathead ran notoriously violently hot. Mechanics fought a desperate war against the temperature. They pulled the factory water pumps and installed high-flow aftermarket units. They ripped the hoods off their 1932 Fords to let the wind hit the iron. They bolted massive, heavy truck radiators onto lightweight roadsters. But physics was unforgiving. To make a Flathead go faster, builders had to perform a machining process called relieving the block, grinding away a shallow trench of cast iron between the valve seat and the cylinder to improve airflow. But doing this removed crucial metal, leaving the cast iron dangerously thin. When the engine inevitably overheated during a race, the stress would cause a hairline crack to form directly between the valve and the cylinder. Once a block cracked there, it was virtually useless. It became scrap. That strength had finally become the trap. The American speed industry had pushed the Flathead to the absolute edge of its breathing capability, and the engine was pushing back. This mechanical ceiling collided directly with Force 1, the harsh realities of iron, aluminum, fuel, and manufacturing costs. To get 200 reliable horsepower out of a Ford Flathead V8 required a massive financial investment in aftermarket parts. A builder needed aluminum heads, a custom intake, an expensive aftermarket camshaft, dual carburetors, and hours of skilled machine work. Even after all that money was spent, the engine was fragile, temperamental, and always on the verge of boiling over. Then the market shifted, and the Flathead's obsolescence became impossible to ignore. The American turning point arrived in late 1949, not from Ford, but from General Motors. Oldsmobile released the Rocket V8, and Cadillac simultaneously released its own entirely new V8 engine. Both of these engines abandoned the Flathead design entirely. They used overhead valve, OHV architecture. The valves were moved out of the engine block and placed up inside the cylinder heads. The difference in efficiency was staggering. Because the valves were directly over the pistons, the Oldsmobile Rocket breathed deeply and exhaled easily. The exhaust gases no longer traveled through the cooling water. The engine ran dramatically cooler, revved higher, and produced far more power with less effort. The Oldsmobile Rocket had a displacement of 303 cubic inches and generated 135 horsepower straight from the factory floor. A massive leap over the Flathead's factory 100 horsepower. But the real shock happened on the street and the drag strip. Young mechanics who had spent thousands of dollars and hundreds of hours building highly tuned, super modified Ford Flatheads suddenly found themselves pulling up to stoplights next to heavy, brand new, factory stock Oldsmobile passenger cars. When the light turned green, the stock Oldsmobile would effortlessly pull away, leaving the screaming, overheating Flathead in its wake. It was a profound psychological blow to the American hot rodder. You no longer needed to be a master mechanic to go fast. You just needed enough money to buy an Oldsmobile. The aftermarket industry, the very ecosystem that the Flathead had built, recognized the shift immediately. Vic Edelbrock, Ed Iskandarian, and the other speed pioneers were loyal to performance, not just to Ford. They bought Oldsmobile Rocket and Cadillac OHV engines, put them on dynos, and realized how much untapped potential the overhead valve design possessed. Soon, the catalogs that had exclusively featured Ford Flathead parts began offering aluminum intakes and hot camshafts for General Motors engines. The Flathead was still the most common engine in America. It was still the cheapest to buy in a salvage yard. But at the absolute bleeding edge of American performance, it was no longer the king. The Oldsmobile Rocket had cracked the Flathead's dominance, but the engine that would permanently bury it was already being cast in a Chevrolet foundry. In 1955, the fatal blow arrived. It did not come from a boutique racing shop in California. It came from a massive General Motors foundry. Chevrolet, the brand that had spent 2 decades losing the V8 Torque war to Ford, introduced the small block V8. Designed under the leadership of engineer Ed Cole, the small block was an overhead valve masterpiece. It displaced 265 cubic inches and weighed significantly less than a Ford Flathead, thanks to advanced thin wall casting techniques. But its most devastating feature was its efficiency. Out of the crate, a stock 1955 Chevy small block produced 162 horsepower. For the American hot rodder, the math changed overnight. To get 160 reliable horsepower out of a Ford Flathead, a mechanic had to spend hundreds of dollars on an aluminum Edelbrock intake, Offenhauser heads, dual Stromberg carburetors, a custom Iskandarian camshaft, and expensive block-relieving machine work. Even then, the engine was a fragile, overheating grenade that required constant maintenance. With the new Chevrolet, a young driver could buy a stock engine from a salvage yard, bolt it into a 1932 Ford chassis, and instantly outrun a fully built Flathead, without ever taking the valve covers off. The aftermarket industry, the exact ecosystem that the Flathead had created, is fundamentally ruthless. It is governed by speed and physics, not nostalgia. When the speed equipment manufacturers realized that the new overhead valve engines responded to aluminum intakes and larger carburetors even better than the Flathead did, the migration was instantaneous. Vic Edelbrock bought a 1955 Chevrolet, took it back to his Los Angeles shop, and immediately began casting aluminum manifolds for it. Ed Iskandarian began grinding high-lift camshafts for the Chevy block. The catalogs that had once been thick with Flathead parts began to dedicate their front pages to General Motors equipment. The parts counters at local speed shops cleared their front displays. The very network of dealers, machine shops, and mechanics that had kept the Flathead dominant for 20 years simply packed up and moved to a better piece of iron. Ford themselves had already seen the writing on the wall. By the early 1950s, the American automotive market was shifting rapidly. The interstate highway system was expanding, and drivers expected to cruise at 70 miles per hour for hours on end. Cars were getting heavier, loaded down with thicker steel bodies, automatic transmissions, power steering, and air conditioning. The Flathead simply could not generate the torque required to pull these massive new passenger cars at modern highway speeds without boiling its cooling water. Ford could not afford to hold on to its history. In 1953, coinciding with the company's 50th anniversary, the last American-made Ford Flathead V8 rolled off the assembly line in Dearborn. In 1954, Ford introduced its own modern overhead valve replacement, the Y-block V8. The architecture that Henry Ford had stubbornly forced into mass production 21 years earlier was officially dead at the factory level. Out on the dry lakes of El Mirage and the salt flats of Bonneville, the transition took a few more years, but the mechanical reality was undeniable. The National Hot Rod Association, founded in 1951 to organize the chaos of drag racing, began to see the Flathead disappear from the top-tier elimination rounds. The sound of American racing changed. The deep, stuttering burble of the Flathead was replaced by the high-pitched, metallic, high RPM scream of overhead valve Chevys and Oldsmobiles. By the late 1950s, if you were still running a Flathead in a serious drag race, you were no longer a pioneer. You were a traditionalist. You were stubbornly racing the past. The engine had gone from being the cheapest way to go fast to becoming a specialized, expensive, and stubborn man's game. The engine still ran. The racers moved on. The factory line stopped. The rule books favored a new design. The aftermarket catalogs changed their covers. The blocks cracked under the heat. The sound faded from the drag strip. The era of cheap cast iron was over. The engine was obsolete, but the culture it created had already taken on a life of its own. The Ford Motor Company never looked back. After 1953, the massive foundries of the River Rouge plant retooled. The Y-block gave way to the Windsor, the FE series, and eventually the modular V8s of the modern era. In the corporate history of Detroit, the Flathead was simply an early chapter, a primitive, inefficient piece of pre-war cast iron that had finally been retired. But engines do not only belong to the factories that cast them, they belong to the people who turn the wrenches. While the hardcore drag racers and the top-tier speed shops migrated to the Chevrolet small block and the Chrysler Hemi in the late 1950s and 1960s, the Flathead did not go to the scrap heap. Instead, it transitioned from a cheap, disposable racing motor into something entirely different, a mechanical heirloom. And in one of the strangest footnotes in automotive history, the engine actually survived by leaving the country. While American production ended in 1953, the tooling and manufacturing rights were eventually acquired by the French military. For decades, the French government needed a simple, rugged, high-torque engine for their Simca Marmon tactical military trucks. They set up foundries and continued casting the Ford Flathead V8 all the way into the early 1990s. Today, these are known in the American hot rod community as French blocks. For a modern engine builder, finding an unused French block is like striking gold. Because they were cast decades later for military use, the French foundries use vastly superior metallurgical alloys. The iron is thicker, the block is far less prone to cracking, and it can handle high-performance heat far better than Henry Ford's original castings. American mechanics now import these military blocks back into the United States, paying thousands of dollars for the privilege of building a 1930s American hot rod using 1980s French military iron. This bizarre global supply loop is a testament to just how deeply the Flathead is embedded in American garage culture. Today, an entire preservation economy exists solely to keep this specific engine alive. The original aftermarket pioneers, companies like Edelbrock and Offenhauser, still manufacture and sell the exact same finned aluminum cylinder heads and intake manifolds they designed in the late 1940s. At swap meets in Pomona, California, or Hershey, Pennsylvania, collectors will pay premium prices for original Stromberg 97 carburetors, vintage Fenton cast iron exhaust headers, or an authentic Iskandarian camshaft still resting in its original cardboard tube. The engine has completely reversed its economic position. In 1948, a returning GI could buy a salvage yard flathead for $50 because it was obsolete. Today, building a reliable, high-performance Flathead V8 with period-correct aluminum parts can easily cost $10,000 to $15,000. The mechanics who spend this money are not doing it to set top speed records. A modern, fuel-injected four-cylinder economy car produces more horsepower than a heavily modified Flathead. They build them for the sound, the look, and the history. They build them to preserve a specific mechanical language. This is not simply nostalgia. A restored Ford Flathead V8 sitting on an engine stand is a physical argument about the birth of an American industry. Before this engine existed, if a man wanted to go fast, he had to be wealthy enough to buy a bespoke, factory-built luxury car. Power belonged to the elite. The Flathead changed that equation forever. It proved that a cheap, mass-produced block of iron could be taken apart, modified in a home garage, and forced to produce terrifying speed. It was the engine that taught America the concept of bolt-on performance. It created the speed catalogs, the independent machine shops, the drag strips, and the multi-billion-dollar automotive aftermarket. It trained a generation of mechanics to look at a factory machine and ask how to make it better. The Flathead proved that power did not solely belong to the engineers in Detroit. It belonged to whoever had the tools, the courage, and the willingness to push the iron past its limits. America did not stop needing horsepower. It simply stopped needing that specific architecture. The valves moved to the cylinder heads, the carburetors gave way to fuel injection, and the mechanical linkages were replaced by software. The engine bays of modern cars became sealed, plastic-covered environments, explicitly designed to keep the owner out. But the Flathead remains the ultimate open invitation to the mechanic. Somewhere in an American garage, a 1932 Ford Roadster sits quietly, its side hood panels permanently stripped away. Under the warm glow of a shop light, the flat iron block rests between the frame rails, topped with heavily finned aluminum heads and twin carburetors. The pull of the starter motor gives way to a deep, stuttering, rhythmic burble, an uneven mechanical idle that echoes off the concrete walls. It is waiting to be driven, not to outrun the law, and not to set a record on a dry lake bed, but to remind the neighborhood exactly what the birth of American horsepower sounded like. See you in the next one.